carboxylic acid contains a carboxyl functional group attached to a hydrocarbon. So we'll start off with the hydrocarbon. Now, a carboxyl group contains two components: a carbonyl group, which is a carbon double bonded to an O, and a hydroxyl group, also attached to the same carbon. Now, this carbon is known as the carbonyl carbon. So since we include the carbonyl carbon in identifying the parent chain, that makes 1, 2, 3, 4 carbons. Now, after identifying the parent chain, you start off with the alkane name corresponding to the number of carbon atoms. So for 4 carbon atoms, that would be butane. However, for carboxylic acids, you drop the E and add oic acid. Now, there's 1, 2, 3, 4, 5 carbon atoms. The alkane name would be pentane. And if you were to name the carboxylic acid, you would drop the E and add oic acid. Now that we can successfully identify the parent chain, we can move on to step 2, which is to name any alkyl group substituents. The alkyl group substituents are the carbons and hydrogens that branch from the parent chain. So an example would be branching from this carbon could be a CH3, which is methyl, or you can have it from different positions and different alkyl groups. So this could be CH2CH3, which is ethyl. So that is the naming part of these substituents. So this is methyl and this is ethyl. Now we can move on to step 3, which is to determine the point of attachment of the alkyl groups to the parent chain. This is done by numbering the parent chain. In the case of carboxylic acids, you always begin numbering with the carbonyl carbon as number 1 and continue numbering each carbon in the parent chain from there. So as we said before, the carbonyl carbon is the carbon that is attached to the double bonded O. So if we start here, this is position number 1, this would be 2, 3, and 4. So now we have the positions of the alkyl group substituents. Now we can move on to step 4, which is the actual construction of the carboxylic acid name. This is done by placing the alkyl groups in alphabetical order with the number for the specific position, followed by the name of the parent chain. So in this case, it would be the names that we have. We have the methyl on position 2 and ethyl on position 4 of the parent chain. So the names that we have is 2-methyl. When naming, we use dashes in between letters and numbers. So 2-methyl dash 4-ethyl. However, this is incorrect because we have to do it in alphabetical order. So E comes before N. So it would be 4-ethyl dash 2-methyl. followed by the name of the parent chain, which we identified as butanoic acid. So, the name for this carboxylic acid is 4-ethyl-2-methyl-butanoic acid. So let's go through this example step by step. Step number 1 is to identify the parent chain. We have 6 carbon atoms, so that would be hexanoic acid. Step 2 is to identify the alkyl group substituents, and we have a CH3 and a CH3. Those are the same. It's a methyl, and this one up here is ethyl. Now moving on to step 3, we have to position these alkyl groups. So remember, we always start with the carbonyl carbon as number 1 and continue numbering from there. 3, 4, 5, 6. Now step number 4 is actually constructing the name. So we have methyl and ethyl. Ethyl comes first because the E comes in the alphabet first. So the position 4 dash ethyl dash. Now we have 2 methyls. We want one on the 3 position and one on the 6 position. And we always separate numbers with a comma. So 3, 6 dash. Since there are 2 methyls, you use the prefix di, methyl, followed by the parent chain name, which is hexanoic acid.
What are you eating?
A butter croissant.
Do you know that carboxylic acid is in butter?
Really now?
Yeah, it's true. Here is the structural formula. Can you name that?
Okay, so it has 1, 2, 3, 4. So butanoic acid?
Yes, oh my gosh.